So what we're looking at is how humans grapple with their water systems. In order to get water to your taps, your water is collected in dams, but there's a lot of sediment in there and a lot of gunk in that dam, and they've got to remove that sediment to landfill so that clean water can get to your taps. And that sediment is really nutritious. It's got lots of carbon and nitrogen and nutrients. However, that water then passes from our taps through a city and release feces into it and urine. We release chemicals like oils and industrial chemicals, soaps and pharmaceuticals. And all of that dirt has to be removed from the water system. So we pass it through sewage treatment plants, where again, all of that is sedimented out to landfill. And again, the relatively clean water that's on the other side of a sewage treatment plant is filtered typically through wetlands and into our river system again. In comparison to sort of the ecological balance that happens out there in terms of waste, we know that animals, they consume plants and those nutrients pass through their bodies and they release their feces. As that's dropped where it is, the microbes can access it, the plants can access it, and it fertilizes the soil. And it's essentially a blanket of waste that is well distributed in nature. But in comparison to that, in cities, we release our waste into our water system, and all of that waste is collected as sludge after the sewage treatment plant and dumped in landfill in one spot. And then our soils are also really poor, so we have to add expensive fertilizer. Those are all synthetic, which is not great. So we're looking at creating an ecological balance in urban design and urban planning, so that when our wastes come out of the sewage treatment plant and the clean drinking water treatment plant, we can divert that. Scientists across the world have shown that it is safe to process those wastes and create essentially composts out of those wastes.
I think as well as considering the risks of returning our waste materials to soil, we need to consider the risks of not returning them, because soil is living and basically we've been killing our soils. So we know that 2/3 of all soils globally are degraded because we've been taking more out than putting in. So particularly micronutrients like zinc, it's kind of been a one-way traffic. We've also been compacting soil, which squeezes the air out of it, meaning that the soil microbiome, which is the living part of the soil, can't do its job. Basically, it can't store carbon, it can't hold water, and it can't grow plants. Because soil is the largest store of organic carbon in the world, it can help us to achieve net zero and address climate change, but we have to look after it. So that's why I'm interested in returning the waste to the soil. It's to look after the living soil microbiome and to help reverse a lot of the damage that we've done to soils. One thing we know is that adding fresh minerals and fresh organic matter improve the soil environment, and that makes more space for the microbiome to breathe. That means that the soil microbiome is healthier. Although we see it as waste, and we do have to, as engineers working with soil scientists and microbiologists, make sure that it is safe to return to the land, we can do that. We can optimize the amendments so that they aren't harmful, but are in fact benefiting the soil microbiome.
So within the Western Cape, it's been proposed, for instance, that we can co-amend these sludges, particularly in these swaths of sandy soils that we know are a local problem. We've got so much nutrient-poor sandy soils, and it's very expensive to amend fertilizers and compost. So looking at urban planning to use these wastes would be very beneficial, especially to grow things like textile crops, such as hemp and cotton, because most people don't want to eat edible crops that are grown off of wastes.
So by adding these fresh mineral surfaces, a lot of these minerals, like iron oxides and manganese oxides, are able to immobilize things like potentially toxic elements, things that can be harmful, like lead and arsenic. It's not that we would ignore those risks. We would very much have to pay attention and optimize our technologies to address those risks.
So we know that there are some risks to this. The sewage sludges especially, if you put it in something like a loose sandy soil, you've got a lot of nutrients and a lot of toxins, and those can wash right through the soil into our groundwater or into our rivers. But the science behind this design is that you can co-amend it with a clean drinking water treatment sludges, which are essentially like building a sandy soil with the clay, and that clay traps the nutrients, it traps the toxins, and holds it within the soil so that the microbes and plants can get to it. That's essentially what we call bioremediation. And this whole thing is a version of what we call biomimicry, copying nature to redistribute our waste into a circular economy rather than the linear waste dumping that's currently happening in urban design.
Is it worth the risk of not land applying our sludges? The production of commercial fertilizers has a huge carbon footprint, and relies on unrenewable mineral resources. So just like we frown upon the use of single-use plastics, we should also frown upon the use of single-use plant nutrients. So shipping these plant nutrients off to a landfill site is really nonsensical, and we need a way to close that nutrient loop and start reusing those nutrients in the crops that we produce. But of course it can't be without risk, but I'm absolutely convinced that if we put our minds to it through scientific investigation and through making the procedure safe, not only in the treatment plants, but also with the amendments that we co-apply with the sewage sludge, we can definitely start seeing sewage sludge as a tangible source of reused nutrients.
We know that this is a really good idea scientifically, and we also know that the finance is a good idea. It's been referred to as Rumpelstiltskin, turning straw into gold, because you're taking something that's really wasteful and turning it into beautiful compost, rich soil amendment, and we can sell that compost. The reason that we think this risk is worthwhile is because scientists have been studying the safety for a very long time, and we know that the problem is a barrier to market and public perception. It is also our responsibility to grapple with our own wastes. The argument is often not in my backyard, and we want to get public to become aware of the waste. There are some ways to do that. Public policy is going to be shifting soon, and we can also watch the commercial companies. There is a company who's targeting the tenders to reutilize our sewage as compost, and they're also going to be working in neighborhoods so that you can release your own waste to them. They will collect it and bring compost back to you.
Biologists say everything is everywhere and the environment selects. By returning waste to land, I think we can improve the soil environment so that we can restore soil health and degraded soils.
So we know it's a scientifically good idea, we know it's a financially good idea, and it's really at the point of barriers to market and public perception. So really the question we're asking people is, would you be willing to buy products that are grown on waste? And what are you willing to do to grapple with the responsibility of waste?